Lesson 10.4 notes. This is on zero and negative exponents. The key ideas are that for any non-zero number a to the 0 power equals 1. I copied this from the textbook, and the equal signs did not print clearly. So any number to the 0 power is equal to 1. The power 0 to the 0 power is undefined, right? You can't, 0 to the 0 is not equal to 1. For numbers, that would mean that 4 to the 0 power would be equal to 1. And a to the 0 power is also equal to 1, and a cannot be equal to 0. For negative exponents, any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. And that sounds like a lot of numbers and is confusing, but once we do a few examples, this is actually pretty easy to handle, and it gets to be kind of fun. It's like working a little puzzle to simplify everything down into just its simplest form. So for numbers, if you have 4 to the negative 2 power, that is equal to the reciprocal, which is 1 over 4 squared. So if it was negative in the numerator, then you move it down and make it positive in the denominator. Okay? And for a to the negative n, that is equal to, we're going to flip it, this would be like having it over 1. So you move the 1 into the numerator and flip it and make a over n positive in the numerator. Okay, and again, a cannot be equal to 0. Right? I think I'm going to write a little note here. So this is a little trick. If the negative exponent is in the numerator, then you move it to the denominator. And if it's negative in the denominator, then you're going to move it to the numerator. Okay, that's going to be like a little trick to follow. Okay, let's do a few problems. So if you have 3 to the negative 4 power, then by the negative exponent rule, that means that you're just going to flip it to its reciprocal. So that is over 1. So we're going to put 1 in the numerator and then move this down to the denominator and make it positive. 3, and then you need to evaluate that number. 3 to the 4th power is 81. So that's 1 over 81. All right. When we simplify, we try to not have negative exponents. So you are getting rid of the negative exponent. All right. So for b, we have the same base multiplied together. By the product of powers rule, we realize that we can just add powers together. So I have negative 8.5 to the negative 4 plus positive 4, which is the same as negative 8.5 to the 0 power. Oh, and by the 0 exponents rule, that means that that is equal to 1. Any number to the 0 power is equal to 1. Right? For C, you have the quotient of powers rule. We've got the same base, 2. So I'll have 2 to the 6 minus 8. That is 2 to the negative 2. And then by the definition of negative exponents, I'm going to write this as a reciprocal. So I'll have 1 over 2 squared, which is 1/4. Right? So when we had a negative number in the numerator here, we just moved it down to the denominator and made it positive. And then there will be other examples where we do just the opposite, where the negative is in the denominator, and we're going to move it up to the numerator. You have 3 U tries, and they are just like what we just did in the example. But the next 3 U tries are a little trickier, so I want to get you started. This one should be okay. You're just going to subtract the 5 minus 6. That'll give you a negative, and then you can use your negative exponents rule. There are several ways to go about 5 and 6. I'll just kind of get you started. 1 over 5 to the 7th, you can leave that the way it is because it does not have a negative exponent in it. And then here you have the negative exponent in the denominator. So to take the reciprocal, you flip that into the numerator. Right? And then you can multiply. There are several ways to handle that. You could do some cross canceling, and you could cancel out the 4, and you could change the 7 to a 3, and that would work. Or you can multiply them, and you end up with 5 to the 4th over 5 to the 7th. And then you can do, I think it's easier to cross cancel. It's kind of like we're doing and then undoing. You'll have 5 to the 4 minus 7 is negative 3, which then flips over and is 1 over 5 to the 3rd. And then you need to evaluate that, which makes it 1 over 125. I should have let you do that instead of me doing it. All right, same thing here. Several different ways to go about that. Essentially, you're going to move the 4 to the negative 3rd needs to go into the denominator. So I'll get this one started, and then I'm going to leave it for you. So we're going to do 4 to the 5th, 4 to the 2nd, and then because this is 4 to the negative 3rd in the numerator, you're going to do the reciprocal and move it to the denominator. Okay, and then you can do the math. Use the quotient of powers property, the product of powers property, and get it simplified. All right. All right. Key point that we're looking at in example 2 is that this exponent only goes with the variable. If we wanted that exponent to go with everything, it would be in parentheses. All right, so we're only taking x to the 0 power. So I'm going to bring the negative 5 over, and I know that any number to the 0 power is equal to 1. So negative 5 times 1 is negative 5. All right, lots of times kids will say, oh, there's a 0 power, this must be equal to 1. But the 5 is not to the 0 power. Same thing here. The 9 is not being raised to the negative 3. The 9 is still just 9, so let's bring it over. Now I've got y to the negative 3 in the numerator. I want to make that the reciprocal, so I'm going to drop it down into the denominator. And then the y to the 5th stays in the denominator because it is not negative. And now we've got 9 over product of powers property, y to the 8th power. Right. Let's look at these. This should be fine. This should be fine. This should be fine. Remember that you are not raising the 15 to the 9th power, and you are not raising the 8 to the negative 2 power. the exponent is only attached to the variable. Okay. And then in our real life example, we have a leaky faucet. And we're always worried about water in California. This is a -2. And once you do the math, you can see why that's such a significant thing. If you have a drop of water and it only leaks 1 drop every second, so that's not even that much. We're going to look at how many liters of water leak from the faucet in 1 hour. And so the first thing you have to do is to convert that hour into seconds. And you start out with the hour that you have, and you want to move towards seconds. Right? So we're going to find out. So we want the hours to cancel out and just leave you with seconds at the end. So I know that to get from hours to seconds, I'm going to go through minutes, and I know that I have 60 minutes in an hour. You could also write 1 hour is equal to 60 minutes. So you could have the flip, right? But I want the units to cancel out, so I'm going to put the hours in the denominator and the minutes in the numerator. And same here, 1 minute is also equal to 60 seconds, so I could have written it the other way, but I want for the minutes to cancel out. Right? So once we get the units canceled, the hours will cancel out, and the minutes will cancel out, and that will change me just into seconds. Right? Lots of times, if you can't figure out quite what to do, you can let the units kind of drive the problem. The units will help you to set things up and kind of figure out what to multiply together. All right, then we've got 60 times 60. That's 3,600 seconds. So we've got how many liters of water leak from the faucet in 1 hour? That's 3,600 seconds. Here's the rate that it's leaking. So we're going to multiply the time by the rate, and that will give us the amount of water that we lose. So we're going to take the time, which is 3,600 seconds, and we're going to multiply that by this rate, which is 50 to the -2 liters per second. And I'm going to go ahead right now and just cancel out those seconds so that I know my answer is going to be in liters. And then that is going to be equal to 3,600 times this 50 to the -2, and negative means that it has to do the reciprocal, so we're going to move it to the bottom. And then 3,600 times 1. Whoops, that's not 5 squared, that's 50 squared. Okay, 50 squared is 2,500. And then I want my answer as a decimal. Here's my thing. So I'm going to do 3,600 divided by 2,500, and that is equal to 1.44. So I have 1 44 liters. So in 1 hour, my faucet has leaked almost 1.5 liters. Imagine how much that would be in a day, in a week, in a month, in a year. That's why it's important to get leaky faucets fixed. Right? And then you have a U-try that is essentially the same thing, except that they're having you try that with 5 to the -5. Right? And you have a calculator, so that shouldn't be too tricky.